Given the tables of coffee sales in thousands of dollars, place the data into matrices A sub 1 and A sub 2. Add the matrices A sub 1 plus A sub 2 to find A sub 3, a matrix with the sales for the first half of the year. Verify that the addition of matrices is commutative by verifying that A sub 2 plus A sub 1 equals A sub 1 plus A sub 2. Okay, so these are already put into tables for us, and they're both categorized the same. The rows having the same labels in both, and also the columns having the same labels. And so they have the same corresponding labels. And so then that naturally just gives us a way to put these into matrices. And so we can really just use the same numbers in the same order. And then similarly with A sub 2, then if we're going to be adding these, I'll just go ahead and put them in order here. This would be A sub 1, and then we'll put A sub 2, and then again, just in the same order, 12, 22, 24, and so on. Then we can go ahead and just add together the corresponding entries. And so the first one would be 28 plus 12, and then 35 plus 22, 42, and notice I'm just taking each corresponding entry, plus 24, and so on. I'll go ahead and do the next column. So then adding these together, then for the first one, 28 plus 12, we get 40, 35 plus 22, 57, and so on. We can just go ahead and add together each of those things that we had. So now we have our final matrices, 40, 57, 66, 57, 83, 63, and then we just want to verify that the addition of these matrices is commutative by switching these. So if we switch the order of A2 and A1, and then that would basically just end up switching each of these numbers. So instead of 28 plus 12, we would have 12 plus 28. Instead of the next one, we'd have 22 plus 35, 24 plus 42, 19 plus 38, and so on. So basically all of our numbers would just switch the order. And then we know that in normal numbers, if you switch the order, then it still adds normally. And it will be the case here. When we go ahead and add these together, 12 plus 28 is still 40. 22 plus 35 is still 57, even though we switched the order. And so we do end up getting the same matrix. So this is the third matrix, A sub 3, and so we can go ahead and summarize our answer. The matrix A sub 3 is 40, 57, 66, 57, 83, 63. Addition of matrices is commutative since addition of real numbers is commutative.